Hi everyone! In this video, we're going to be talking about the 5-number summary and box plots. Recall from the other notes that box plots are used for measurement data, and this is the same sample data set for scores for a final exam. And note that I put how many elements are in the sample. There's 33 different data values. The first thing that you want to do when you're trying to figure out a box plot or figure out a 5-number summary is to rewrite the data in ascending order. That just means from smallest to largest, and find the maximum and minimum values. I've circled those values in blue. The minimum or the smallest value is 50, and the maximum or the largest value is 97. You can actually calculate the range using the max and min as well. The range is just the max minus the min, which is going to be 97 minus 50, which is going to be 47. Now, we don't use the range in the 5-number summary, but just for calculation purposes, a little sneak preview to measures of spread. After you find the max and min and write every data point in order, the second thing you'll want to do is find the middle number. The middle number is called the median. And there's a couple ways you can do this. You can just do n divided by 2, which is equal to 33 divided by 2 in this case, which would be 16.5, which means you want to circle the 17th number. Or you can go from top to bottom and just start crossing out values, which I'm demonstrating now. This is very easy and straightforward to do. Just cross out top and bottom until you get to the middle. And as you keep going, like maybe do 3 top and bottom each, maybe 3 more top and bottom each, and then you notice that there's only 2 left and we end up at 71. The middle number is in the middle of the organized data set. The median actually breaks up the data into 2 halves, and halves is 50% each. So the median shows you 50% of the data below that number and 50% of the data above that number, just as a marker when we talk about some more terminology to go over. So now we have the minimum value, the maximum value, and the median. After you do that, your third step is to find the middle of the lower and upper halves determined by the median. So the lower middle half you find just like the median. You can cross off top and bottom, or notice that you have 16 elements above 71, 16 data values below 71, and so the middle would be between the 8th and 9th values there. So we have the lower middle half and the upper middle half. The lower middle half, I'll write lower middle half for lower half middle, is half of half. And I bring this up because that just means that it's a quarter. We call that lower middle half a quartile. Quartile 1, abbreviated as Q1. And that just means that from Q1, which for us is going to be between 56 and 57, so we add them up, divide by 2, and we get 56.5. So at Q1, there's 25% of the data below Q1 and 25% of the data between Q1 and the median. Similarly, the upper middle half, which I'm calling upper half middle here, is again half of half. So it's also a quarter, which is quartile 3, called Q3, and we calculate it the same way. 82 plus 83 divided by 2 equals 82.5. Now notice that the quartiles in this case were in between 2 numbers. That's not always the case. It just depends on if your median was a data value or not. When your median is a data value, then your quartiles are going to be in between 2 numbers. If your median is in between 2 data values, then your quartiles are going to be data values. We'll practice this more as we go along, but I just want to show you this one example using the data set from before. So now we have our upper and lower halves. They're called quartiles again. And I say for step 4 is just to record your values, your minimum, your Q1, your median, your Q3, and your maximum. And notice, again, from your minimum to Q1, that houses 25% of the data. From Q1 to the median, that houses 25% of the data. From median to Q3, houses 25% of the data. And from Q3 to maximum, houses 25% of the data. I bring this up because I just said that the quartiles are like quarters. The quartiles are quarter markers, so they represent different 25% throughout the data set. Notice again, from the median to the minimum, that's 50%. And from the median to the maximum is 50%. So like I said earlier, how the median breaks up the data set in half. You get 50% below, 50% above the median. Now, the appropriate way to write your 5-number summary is to just list the values. So you do 50, comma 56.5, comma 71, comma 82.5, comma 97. You do not write any marker of what the 50 represents or anything. It's just understood that 50 is the minimum, all the way through 97 is the maximum. That's how you determine your 5-number summary. Now that's the first part of this video. The next part is to take that 5-number summary and build your box plot. From there, you want to calculate your interquartile range. It's called an IQR. Your IQR is just Q3 minus Q1. Notice that's just 82.5 minus 56.5, which gives you 26. And step 5 is like 2 parts. The second part is to calculate the fences and check for outliers. The fences, think about a fence for like your garden. The fence keeps out different, like, I don't know, maybe foxes from coming into your garden, let's say. And so the lower fence determines what is too small to be included in okay range. And I said that in quotations because it's just based on some calculation that mathematicians from before gave us. And your upper fence does the same job and says which data values are too big to be included. That calculation is just a formula. You'd, for the lower fence, take quartile 1 and you look for any values that are 1.5 times the IQR below Q1. That 1.5 just comes from, again, calculations mathematicians did, but it's just the distance away from Q1 and then half amount more. Notice the lower fence says any number below that 17.5 we omit. Well, our minimum was 50, so we're not going to omit anything. There's no lower outliers. Similarly, for the upper fence, it's just Q3 plus IQR times 1.5. And when we do the calculation here, we get any number above, in this case, 121.5, we would omit. But our maximum value was 97, so there's no upper outliers. This is not always the case. You can have outliers, but in this data set, there were no outliers. Again, outliers are just data values that are very far away from the rest of the data. It's as if somebody didn't come take the final and got a 0. That would have been an outlier. So now that you've finished steps 1 through 5, your last step is to make your box plot. I've graphed it already using the colors that we have, but let me show you how I would set up this box plot. So the first thing I like to do is draw a number line and make stuff as equidistant as possible for myself, just to make sure that I get everything organized. We had our 5-number summary was 50, 56.5, 71, 82.5, and 97. I'm just reminding myself of these values, and I'm going to hold them off to the side and then erase them afterwards so that I can plot everything properly. When I do this, I like to work from the inside out. So I'll graph the median first. The median at 71 is just a vertical line. You get vertical lines for the quartiles as well. So the next thing I'll do is plot 56.5, best as I can. Then I'll plot 82.5, best as I can. And this is where the box comes in. You connect all of these vertical segments to create a box. And it doesn't have to be perfect. We just try our best. From there, or again, working inside out, I will then put dots at the ends where my maximum and minimum are. So I put a dot in the middle of the box at 50 and draw a line to the middle of that box. And on the other side, I'll put up a dot at 97 and draw a line to the middle of the box. If we had an outlier, let's pretend, and I'm going to put it in purple for a moment, let's pretend that 100 was in fact an outlier. Even though we can see right above here, any number above 121.5 would be an outlier. Let's just pretend for a moment that 100 was an outlier. You would just draw a dot wherever the outlier was. Your outlier could be your maximum, so that would just mean you'd have to move in to your next largest value. We'll do an example of this if it arrives as something we need to take care of, but otherwise it's really just straightforward of plotting your 5-number summary and checking for outliers in case there are any. If there's any questions, please don't hesitate to email me or talk to me about it in class or put it in a discussion post. I hope this helped to understand the 5-number summary and box plots. I'll talk to you soon.